Welcome to AI Paper Podcasts, where we decode the latest research so you can stay at the bleeding edge. Today, we're ripping into a paper that really gets at the heart of where AI agents are heading. How do we unlock their incredible potential when they're still, well, a bit flaky?
That's right. Imagine AI agents that can browse the web, write and execute code, even manipulate files, all to complete these complex multi-step tasks autonomously. That's the exciting promise.
Yeah, the dream scenario.
Exactly. But the reality is, even with today's most advanced LLMs, these agents often fall short of human-level performance in key areas like, say, general computer use or software development. And crucially, their growing autonomy introduces brand new safety and security risks. Think misaligned actions or even, adversarial stuff like prompt injections.
Exactly. So what's the game changer? It seems it's bringing the human squarely into the loop, and that's where this paper on Magentic-UI comes in.
Precisely. It's an open source research prototype, and it's designed specifically to enable effective, low-cost human involvement in these powerful agentic systems.
So it's about blending our human smarts and oversight with AI's efficiency.
Yeah, Magentic-UI's core innovation isn't just one thing. It's really a suite of 6 clever mechanisms. Co-planning, co-tasking, action approvals, answer verification, memory, and multitasking.
Okay, quite a few there.
Yeah, and together, they're engineered to guide these agents through real-world ambiguities and complexities. It allows us, to squeeze maximum productivity out of imperfect AI systems by truly combining human strengths with AI capabilities.
So it's not just a tool, it's kind of a new paradigm for partnership.
That's a good way to put it.
Our mission today then is to unpack this paper, explore how Magentic-UI aims to overcome these current limitations of autonomous AI agents, and make them genuinely useful and safe partners for those tricky real-world tasks.
Right.
And if you're an AI researcher or ML engineer listening, this is pretty critical for understanding the future of human-AI interaction, agent safety, and, robust system design. Let's dive in. So before Magentic-UI came along, we've seen this incredible surge in capable AI agents. You've probably heard of or even played with things like Operator, Claude Computer Use, Open Hands, maybe Devin, or Deep Research.
Oh yeah, absolutely. Those systems really showed what might be possible. They can interact with environments, use various tools, tackle long-running tasks. They definitely pushed the boundaries.
But they hit walls, didn't they?
They absolutely did. Despite all that horsepower, some pretty significant walls. The first, and maybe most obvious, is a noticeable performance gap.
Right.
They consistently fall short of human-level performance in areas like general browser use, software development, deep research, even customer support. They can handle a lot, but they're not quite at our level for complex, nuanced tasks yet.
And it's not just about performance, is it? There are some serious safety and security concerns that pop up when you give these agents more autonomy.
Huge concerns. Yeah, we're talking about entirely new attack surfaces. Think about adversarial manipulation, like those prompt injections where malicious instructions are subtly hidden on a web page.
Ooh, tricky. Very. Or even just a basic misalignment between what the agent does and what you actually intended, maybe leading to irreversible actions or violating your preferences, or worse, exposing private data. That's a huge roadblock for real-world deployment.
This is exactly the core problem Magentic-UI set out to solve then.
Yes. Their central idea, their thesis, is that human-in-the-loop, or HIL Agentic Systems, are the crucial way forward. By weaving in human oversight and control, we can unlock immense productivity from these imperfect systems.
Makes sense.
And even when we look to the future, with even more capable agents, human involvement will likely remain essential. It's about maintaining human agency, resolving those inevitable ambiguities that pop up in the real world, and guiding agents as conditions change. It's really a vision of partnership, not just handing over the keys.
What's truly exciting about Magentic-UI is that it's not just some academic idea. It's a tangible, open-source web interface. You can actually use it. Exactly. It's built specifically for developing and studying these human-in-the-loop agentic systems, acting as an end-user application. So if you're an AI researcher or ML engineer, you can actually get your hands on this and experiment. It's a platform for discovery.
And the architecture sounds pretty interesting too.
Oh, it's really well thought out. It's built on a flexible, multi-agent system, drawing inspiration from frameworks like Magentic-1, but adapted specifically for interactivity and human-agent communication.
Okay.
At its heart is a lead orchestrator agent that directs the other agents. But here's the really clever part. You, the human user, are actually treated as a special user proxy agent within this whole multi-agent team.
So you're not just a user of the tool, you're an actual member of the AI team. That's cool.
It completely changes the dynamic, puts you right in the middle of the action.
And in terms of capabilities, Magentic-UI is quite versatile, right? It supports web browsing, code execution, file manipulation.
Yep, all of that. Plus, it's highly extensible. Developers can integrate all sorts of diverse external tools using something called the Model Context Protocol, or MCP. So it can potentially connect to, well, almost anything you can imagine.
Wow. Okay. And security, if it's doing all this stuff.
Security is absolutely paramount, and Magentic-UI bakes this in from the ground up. All agent activities, browsing, coding, file stuff, are rigorously sandboxed within Docker containers.
Right, the containerization.
Think of it like a secure, isolated playpen for the AI. This separation is critical for mitigating risks, preventing unintended access to your machine, or stopping malicious actions. Docker really forms the bedrock of its security.
Okay, good to know. Now let's get into those 6 brilliant interaction mechanisms Magentic-UI uses to achieve this low-cost human involvement. First up, you mentioned co-planning.
Right, co-planning. This is where you and the agent work together to create a plan before the agent even lifts a digital finger, like a crucial strategy session up front.
Okay, what are the benefits there?
Well, the benefits are huge. It helps resolve ambiguities right away. Imagine you ask the agent, buy a charger for my Surface laptop. The agent might initially plan to search Amazon.
Standard procedure.
Yeah, but you, with your human knowledge, might know it's only sold on Microsoft.com. Co-planning allows you to inject that specific knowledge and correct the plan before the agent wastes time and effort.
Preventing those costly detours later on. Measure twice, cut once for AI.
Exactly. It also gives you invaluable oversight, lets you relax a bit during execution because you know the basic plan is sound.
It's smart because it taps into our own planning smarts. How does it work in the UI?
It's pretty slick. The orchestrator will ask clarifying questions if your request is ambiguous. Then it generates a natural language plan, which you can easily edit right there in the UI or even through text messages.
Oh, text messages too. Nice.
Yeah. Once you're happy, you explicitly click Accept Plan to kick off the execution, and a progress bar keeps you updated. They have an example like ordering a custom pizza Magentic-UI, lays out the steps, you tweak them, then it starts ordering.
Very collaborative. Okay, what's next after co-planning?
Next, we have co-tasking. This is all about collaborative execution. It allows you and the agent to fluidly hand over and take control as needed. It's designed to handle those inevitable roadblocks mid-task.
Like a product being out of stock or the agent just getting a bit sidetracked.
Precisely. And there are 3 main ways this plays out. First, you, the user, can interrupt Magentic-UI at any point. Hit pause, provide clarifications, tweak steps, or even jump directly into the embedded browser yourself.
Oh, like grabbing the steering wheel.
Exactly. Maybe to pick a very specific shuttle seat in a booking scenario that the agent missed. The UI explicitly tells you you have control, and Magentic-UI then gets notified of your changes.
Okay, that's direct intervention. What else?
Second, and this is where it gets really efficient, Magentic-UI can ask you for help. The orchestrator can actually delegate specific steps to the user proxy that's you.
So the AI asks me for help.
Yeah, but only when it's truly stuck, typically after other agents have tried and failed. Think CAP-TCAs. Or if a product is out of stock and it needs you to decide on a substitute, it smartly defers to human ingenuity when necessary.
That avoids unnecessary interruptions, which is good. And the third way?
And finally, there's final answer verification. Once the task is wrapped up, Magentic-UI displays the final result, text, files, whatever. You get to verify it by reviewing the agent's actions or even asking follow-up questions.
Right, the final quality check,
Right,
making
yeah.
sure it did what you actually wanted.
Exactly. Ensures the job was done correctly and to your specifications.
Okay, co-planning, co-tasking. What's the third mechanism?
The third mechanism is multitasking. This is a big one for productivity. It lets users run and monitor multiple tasks simultaneously in different sessions.
Oh, that is a game changer, so I can spin out several agents on different things at once.
Yep. Make partial progress on various tasks, letting you manage and complete them far more efficiently. The UI is designed for this with a left-hand side panel for session selection, creation, and status monitoring.
And you mentioned status indicators.
Yeah, little visual cues. A red dot if the session needs your input, a spinning icon if it's processing, or a green check when it's done. That red dot especially is key for busy folks juggling multiple projects.
I can see that. Okay, multitasking. What's number 4?
And this leads us nicely to the fourth mechanism, agent memory. A huge user expectation is that agents learn from past experiences and adapt for similar tasks in the future, especially for repetitive workflows.
Yes, that's always the hope. How does Magentic-UI handle that?
Well, the system stores what they call saved plans, which are basically task plan pairs, in a gallery. After a task is finished, you can tell Magentic-UI to learn plan from the entire execution trace, and an LLM synthesizes that experience into a reusable plan.
That's brilliant, building up a library of solutions.
Exactly. And plan retrieval is really versatile too. You can directly rerun a saved plan, or Magentic-UI can suggest relevant plans through autocomplete when you start a new task. You can also manually attach one.
And is there automatic retrieval too?
There is. The orchestrator can use something called Autogen's task-centric memory, kind of like a superpowered notebook. It generalizes tasks, embeds them for context using vectors, and then queries a vector database, like ChromaDB, to find and suggest similar stored plans as hints.
So it tries to proactively help you reuse past solutions.
Right. It helps the system get smarter over time without you constantly having to feed it the same instructions.
Right, let's shift gears a bit for our technical audience and peek under the hood.
Yeah.
How does all this Magentic-UI magic actually come together? You said 3 main components.
Yeah, 3 main components. First, there's the agent team itself. This is the multi-agent system, likely based on a framework like Autogen, and adapted from Magentic-UI. It includes that lead orchestrator and specialized agents like the web surfer, coder, and file surfer. And remember, the human is right there as the user proxy agent.
Part of the team.
Exactly. They all share a securely sandboxed workspace and operate within Docker containers for code execution and web browsing. That Docker sandboxing, as we keep emphasizing, is absolutely critical for security.
Got it. Agent team. What's component 2?
Then there's the user interface. This is the web-based application you interact with. It manages your sessions, shows real-time updates, provides that live browser view, and gives you the input box to chat, designed to be intuitive.
Makes sense. The front end and the third.
And finally, the back end, which they call the team manager. This handles creating a new agent team for each session. It manages the WebSocket connections between your UI and the agents, and stores chat history and interactions, probably in something like a Squeak database.
And it handles resuming sections too.
Yes, it takes periodic snapshots of the agent team's state, so you can potentially resume sessions even if you close your browser. Plus, you can apparently change the underlying LLM through the UI, which is great for flexibility when experimenting.
Okay, so how does the orchestrator actually orchestrate all this? You mentioned 2 modes.
Right, 2 key modes. The first is planning mode. When you give it a task, the orchestrator generates that initial plan. It might even search the web or pull from memory to build it.
And presents it as steps.
Yep, a sequence of natural language steps assigned to specific agents. And the crucial part, you can edit, regenerate, or just accept it. True collaboration.
And once accepted,
it switches into execution mode. Here, the orchestrator tracks progress using a progress ledger. If it gets stuck or decides the plan isn't working, it can loop back to planning mode for your approval to replan.
Smart replanning.
Otherwise, it just checks off completed steps and instructs the next agent, web surfer, coder, file surfer, to carry out their assigned instruction.
Speaking of those agents, the web surfer, that's the browser controller.
That's the one. Manipulates the browser, clicks, scrolls, types, and sends back screenshots. Runs in Docker, uses an allow list for websites. If it needs to go off list, it asks for your explicit approval.
Good safety net. And the coder agent.
Yeah. Generates Python or Bash code, executed in isolated Docker containers. If there's an error, it's smart enough to retry generating the code a few times to fix itself.
And the file surfer.
Handles local file operations, finding files, converting formats like PDF to Markdown, running structured queries on file content. Again, all securely within Docker.
And finally, the user proxy agent. That's me, the human.
That's you. Represents the human user, allowing the orchestrator to delegate tasks when needed clarifying questions. CAPI-TCHAs, getting help when stuck. It prioritizes other agents first, though, to minimize bothering you unnecessarily.
Right, trying to be efficient with human time. Okay, let's talk safety and security more, because building trust is huge here. You mentioned the Action Guard system.
Yes, this is a standout component. It ensures irreversible or potentially harmful actions get reviewed by you before execution. It's a smart 2-stage process.
2 stages.
First, it uses heuristics to classify actions. Always irreversible, like uploading files, maybe irreversible, like clicking a generic button, or never irreversible, like scrolling.
Okay, simple categories.
If it's always irreversible, you get a simple yes-no approval prompt. Never irreversible, it just proceeds. But for the maybe irreversible ones, an LLM-based judge steps in.
An LLM Judge.
Yeah, it analyzes the action based on criteria like real-world consequences, irreversible changes, data integrity, privacy, impact on others. Think making a purchase, sending an email, typing sensitive info. Those trigger this thoughtful review.
It sounds much more nuanced than just blanket approvals.
It is. And beyond that action guard, Magentic-UI uses layered mitigations. We talked about Docker sandboxing, limiting access to your file system and browser state. Crucially, Magentic-UI uses its own browser, separate from yours.
Right, keeping things separate.
Plus, those website allow lists requiring explicit approval for unapproved domains add another layer.
And they tested this rigorously, red teaming.
They did. The paper details tests against 24 adversarial scenarios, direct risky requests like reading SSH keys, social engineering like phishing pop-ups, even those sneaky cross-site prompt injections.
Okay, how did it hold up?
And here's the critical takeaway, the real aha moment. With Magentic-UI's default layered mitigations enabled, none of these attacks worked. The system either asked for approval or was blocked by sandboxing.
That's impressive.
However, and this is really important, when they intentionally disabled those mitigations for testing, prompt injections were successful. The agent could be tricked into exfiltrating keys, logging into GitHub, searching email, even self-approving actions.
Wow. So those safeguards are absolutely necessary.
Absolutely. Unequivocally necessary.
Yeah.
It powerfully underscores why security needs to be fundamental, not an afterthought. These layers aren't just nice to have.
This also puts a big spotlight on user responsibility, doesn't it?
It really does. The paper emphasizes best practices. Run it in Docker, limit access strictly, don't share unnecessary files, review proposed actions carefully, monitor progress, and approach outputs with healthy skepticism hallucinations happen.
Right, and use good, responsible AI LLM services. It's a shared responsibility model.
Exactly.
So how does Magentic-UI actually measure up in practice? The team evaluated it in autonomous mode and interactive HI mode, right?
Yep. They use standard benchmarks, GAIA, Assistant Bench, Web Voyager, Web Games, tested with both a 4 Mini and GPT-4All LLMs.
And the autonomous results.
In autonomous mode, it basically matched Magentic-1 on GAIA Assistant Bench and was comparable to other SOTA systems on the web benchmarks. So it's a capable agent on its own.
What about runtime?
Interestingly, successful tasks were much faster, median around 114 seconds versus over 230 for unsuccessful ones. Unsuccessful tasks had fatter tails in the distribution, meaning the agent often spent way more time trying different things before failing.
Makes sense. It keeps trying. And planning.
Median plan length was pretty short, just 2 steps usually. But web games, which has a clear success signal, like unlocking a password, had a high replanning rate, over 50%. If it didn't get the password, it kept replanning.
Okay, but the real test is the human-in-the-loop stuff. They use simulated users for that.
Right. Simulated user evaluations on GIIA. One smarter simulated user and one with side information, like a human-written plan.
And what did they find? This is the key part.
Here's where it really clicked. Human-in-the-loop dramatically improved task completion accuracy. With the side information user, accuracy jumped by a massive 71% from about 30% up to nearly 52%.
Wow, a 71% improvement.
Huge. And this incredible performance came at a truly low human cost. Magentic-UI only asked for help from those simulated users in about 10% of tasks, with very few interruptions, average 1.1 times per task where help was needed.
So massive gains with minimal human effort. That's the dream.
It really demonstrates the potential. High performance, low cost.
Did they also do studies with actual humans?
They did. A qualitative user study with 12 participants. The system usability scale score was decent, 74.58. Most found it easy to use, not unnecessarily complex.
What did people see it being useful for?
Mostly information gathering, navigating tricky websites, planning travel, tedious repetitive tasks. They saw it as a valuable co-pilot.
There must have been pain points.
Oh, definitely. Latency was a main issue, especially switching tasks. Though users felt multitasking and action guards could mitigate this by letting things run in the background.
Any other issues?
Model errors came up. Agents not processing fonts right, getting stuck scrolling, map difficulties, not integrating plan changes sometimes, CAPI-TCHA issues. Users wanted the ability to rerun from a previous step after making corrections.
That seems like a reasonable feature request. Verbosity?
Yeah, some found the reasoning text too verbose, plans too wordy, screenshots maybe repetitive. It's always a balance, finding the right level of detail.
Despite those points, how were the actual HIL features received? Co-planning,
Co-planning was valued. Users liked incorporating subjective preferences and the inherent safety perspective. They wanted dynamic plan changes, though.
And co-tasking, being able to jump in.
That was seen as a lifesaver for adapting to frustrating model errors and for keeping control with sensitive info or just general curiosity.
Action approvals, mixed feelings there.
Kind of. Desired for high-risk actions like payments or sending emails. Less so for low-risk things like adding to a cart. Some found repeated approvals a bit excessive.
Okay. And multitasking.
That was a huge hit. Participants felt much more confident letting it run multiple tasks simultaneously because of the HIL safeguards. Some wanted clearer notifications, though.
How did people verify the results?
Mostly visually screenshots. The live browser view were preferred over just text summaries. They wanted more visual aids, maybe flow diagrams or annotated screenshots.
And how did they learn to use it?
Mostly trial and error. Users built their mental model gradually, often unsure of its full capabilities initially. Pretty typical for new, complex tools.
So summing up, Magentic-UI sounds like a really significant step towards effective human-agent collaboration.
It really does. It provides concrete, usable mechanisms, shared plans, clear histories, progress indicators, robust verification. It's a solid foundation.
But challenges remain. Right, it's not perfect.
Definitely not perfect. Aligning the agent's detailed actions with your precise intent is still tricky. Agents sometimes do more than planned in a single step.
And planning flexibility.
Yeah, extending plans beyond simple sequences to include branching or parallel execution is a big next step. And for really long tasks, reducing the cost of reviewing those plans, maybe hierarchical plans or selective feedback, is crucial.
What about information overload?
That's another one. Improving how agents convey progress, especially for background tasks, to avoid overwhelming the user. Maybe smart summaries instead of logs. And tuning interruption sensitivity to match user preference and risk tolerance.
And limitations of the current system.
Well, it's still below human performance for really advanced coding, multimodal tasks, very long web actions, general computer use. It's English only currently. And the study didn't directly measure downstream productivity benefits quantitatively.
But the core message seems clear. Human agency and oversight are fundamental.
Absolutely. Transparent planning, user approval, action guards, sandboxing, red teaming. These aren't just features. They are essential for safe, reliable deployment.
And making it open source is basically an invitation.
Exactly. It's an invitation to researchers and engineers to explore, extend, and contribute to building this future where humans and AI can truly collaborate reliably and safely.
So what's the big picture here? Magentic-UI is a pivotal step, moving AI agents from just autonomous tools towards being real collaborative partners.
Right. By thoughtfully embedding the human into the loop, it lets us take these imperfect but powerful AI systems and turn them into incredibly productive and, importantly, trustworthy tools.
We really encourage you, the listener, to check out the open source project if this sounds interesting. Experiment with the mechanisms. Think how these ideas might apply to your own work.
And maybe a final thought to leave you with. As we continue to develop these increasingly sophisticated AI agents, what new frontiers of human potential will we unlock when we design for true partnership, where AI amplifies our capabilities and we, in turn, guide its intelligence?